Hello and welcome to our video on Gay-Lussac's law. In this video, we'll be focusing on this specific law and how to calculate problems that involve this equation. So again, for reference, Gay-Lussac's law says that whatever my initial pressure and my initial temperature are, those starting conditions, will always equal the final pressure and the final temperature of that gas. Notice how in Gay-Lussac's law, it does not mention anything about volume. That's because in Gay-Lussac's law, volume is always held constant. So that means the only things that change are the pressure, how much those gas particles are colliding, and the temperature, how fast those particles are moving. So let's try a practice problem using this equation. It says if the pressure of a chamber was 100 atmospheres at 600 Kelvin, what will be the temperature of the chamber if the pressure was raised to 600 atmospheres at a constant volume? So again, one of the most important parts of this problem is it says that it's being held at a constant volume. That's how you know that you're using Gay-Lussac's law, because volume does not change. The only things that change are the pressure and the temperature. So let's go over what we know. It says the pressure of my chamber is 100 atmospheres. So 100 atmospheres has to be my P1, my initial pressure. And it says that this is at 600 Kelvin. So that's got to be my initial temperature, my T1. Right? It's asking me what the new temperature of the chamber is going to be. So that's going to be my T2. That's my variable. That's my unknown. Right? And then it says that my pressure is being raised to 600 atmospheres. So my P2 is going up. My pressure is being increased. Right? So I'll ask you for two things, the setup and the answer. So let's start with the setup. Let's plug in what we know into my Gay-Lussac's equation. So P1, it says, is 100 atmospheres. All right, and I'm multiplying that, I'm dividing that by my T1. So what I'll do is I'll just use that little dash to indicate that I'm dividing. And so that'll be my P1 over my T1. And that equals my P2 over my T2. So my P2, my second pressure, my final pressure, is 600 atm. And then dividing by T2. T2 is going to be my x. So that's how I'll set this equation up. And then the last thing that I'm asking for is your answer. So what I'll do is I'll solve it down below, and then I'll write the answer in the box. So it says that I have 100 over 600, and that equals 600 over my T2, which is my x. So when I solve the left side of my equation, 100 over 600, I get 0.167 equals 600 over x. Right, so then I can cross multiply, and ultimately what I get is 600 divided by 0.167. So when I divide 600 by 0.167, what I get is my final temperature, which is about 3592.8 Kelvin. So that'll be my final temperature. And again, I want to make sure that I include my units of Kelvin because that's how we measure temperature in this equation. So for my answer, my T2, my final temperature, is 3592.8 Kelvin.